Yeah, so hi all, very good evening and welcome back to the 10th week of TA Live sessions for AI search methods for problem solving. So, before we move ahead, is my screen visible and is my audio clear? Can you confirm that quickly? All right, thanks for the confirmation. So, a couple of things to say before we start the session. So, I'm traveling this week, so I'm taking this live session from a different place where I usually take it from. So, that brings in a bit of complications. One is that I'll keep my video off today because of the limited bandwidth, so I hope that's okay. And the second is that um, there is some power issue over here, so in case the power goes off in between and I am disconnected from the meeting, don't worry, just wait for maybe a couple of minutes. If I can, I'll join back. Otherwise, if it's not possible to join back, I'll record the whole session and upload it before the deadline, so don't worry about it. Okay, just keeping you all informed so that you don't wonder later on about what happened if something like that happens. But let's keep our fingers crossed and proceed with the session today. And yeah, so today we'll be covering some topics from week 10 of the course, which basically deals with rule-based systems, production systems, and RATINET, and so on and so forth, which is, I would say, compared to the complexity that of problems that you might have come across in the previous weeks. This is a pretty simple week, pretty simple content. So I really encourage all of you to try to understand this and score as much as you can in the upcoming assignments and the exams which have content from this week. Okay, yeah, and to address some of the persistent doubts from the previous sessions regarding the forward state space planning, backward state space planning, and goal stack planning with FSSP, BSSP, and GSP. So again, if we have time and if things are going as per plan, there are no power cuts and things like that. We can try to discuss or go over some of the questions from the week 8 assignments that you guys had. Um, I have also sent a mail to Bhaskaran sir, who is the main TA who usually answers your questions on the discussion forum. And I've asked him if possible to share the or post the complete set of solution on the discussion forum, at least for week 8. So let's see what he says. And yeah, if that can be done, then really good. Um, but yeah, that's what I have. That's the update I have for you as of now on that front. Um, to address one question from Rocky, so can we have a doubt test before the exam date? Um, so unfortunately, I am given only a limited number of these live sessions. I have only 12 live sessions, and that all 12 of them would be consumed in covering the questions from the 12 weeks. But what we can do is maybe in the last week, so the last 2 weeks are really easy. So I don't think we will take a lot of time to cover the questions from the week 11 and 12. So in the remaining time, what we can do is we can utilize that as a doubt clearing session or something like that. But yeah, I don't think I'll be able to give an extra date for a doubt class, at least from my side. But you can try posting in the discussion forum and see if Bhaskaran sir or Professor Khemani himself can be available for something like that. Yeah. Um, any tips for preparing for exams? So I would just say that practice all the assignments and practice assignments well. Try to understand the concept. It's okay if you don't remember every detail of every algorithm or every method. Just try to understand what is being done, and that should be helpful during the exam. Okay. um, with that out of the way, let's start today's session. And yeah, maybe I'll zoom in a bit more. Okay, so this is the first problem setting that we're going to deal with for the first few questions. So we are given two rules over here and a working memory. Um, and we have to allow the production system to run until completion, or until no more rules can be fired, which are just out of these two rules itself. So um, yeah, I'll I'll let you go through the rules and the working memory, and maybe you can also try to work out the solution by yourself first, and then we can discuss the complete solution for this while I try to address some of the messages in the chat box. Um, so how much percentage we can expect from assignments? So unfortunately, again, Shanti, I have no role to play in the decision about the questions in the final exam. So I I can't help you with that. I don't have any idea about it. But maybe if you ask Bhaskaran sir, he can maybe throw some light on that. Um, Also, Amar, I don't have any access to previous year's exam questions. I did try looking for them, but I couldn't find them. So, unfortunately, I don't have access to any of those. Um, and again, how many questions I don't know. Um, from the previous years, I know that both Bhaskaran sir and Professor Khemani have always maintained that if you practice the assignment questions and the practice questions, that should be a good base to give your exam, because as per them, they frame the questions just like the assignment questions. But that's all I know about it. And for any further information, it's better if you write to the NPTEL people, or the TA, Bhaskaran sir, TA, and Professor Kemani himself, maybe. Yeah. Okay. So, all right. So, yeah, I'll give you maybe a couple of minutes, maybe 2-3 minutes, to try to um, solve this particular uh, problem statement. Basically, you try to see, based on the working memory that you are given, try to see which of these rules can be applied, and then accordingly add another fact to your working memory, and then apply the corresponding rule on the newly added fact. And keep applying those rules one after the other, until and unless no rules can be fired or the system has run to a completion. So that would mean that the production system has to halt then and there. Okay. Okay, so what is nat? So nat basically represents, so you could say nat represents a natural number, but in this context, you could say that it is also a class. So what is a class exactly? We'll see more of those as we discuss the rules and the production systems. If you remember from the lecture videos, there is something called OPS 5 that professor might have mentioned about, and that basically has a certain format in which you present these rules. And yeah, we'll see more on those, but for the time being, you can consider that that represents a class of some things that are natural numbers, just for this particular problem, not in general. All right, so yeah, 2-3 minutes, and then we'll discuss the solution. In the meantime, if you have some partial solutions also, you can feel free to post it in the chat box or even unmute yourself. All right. So, would anyone like to share what they think these rules, both these rules, Rule One and Rule Two, imply, or what do they tell us, or what they're trying to do? All right. So we already have a solution. That's great, Sandhya. Good work. Um, does everyone agree with the solution that's been posted in the chat box? Okay, that's great. Um, let's quickly go over the solution for the sake of completeness. I think this is a pretty straightforward question, and most of you will be able to get it. But yeah, so I see your message about the Shanti about the blocks world problem, and I do realize and um, you many of you have been raising this problem since the past many live sessions. So yeah, I'll try my best to at least go over the question from my side, uh, whatever little bit I can. But as I said, I have requested Bhaskaran sir to provide a full solution. Since he has framed the questions, it will be good if he can provide the complete solution as well. But yeah, from my side, I'll try to go over it to some higher level, maybe if I can. But yeah, for the time being, let's try to focus on this problem at hand. So here, what we are given is, yeah. So here, what we have is we have two rules. Okay, rule 1 and rule 2. So this rule 1 and rule 2 is the name of the corresponding rule. Okay, and what each rule does is it has a certain set of preconditions. Let me use a different color to mark it. So these are the preconditions for a particular rule, and once these preconditions are matched, um, then it will this rule will fire, or this will become a candidate to be fired. Basically, when you fire a rule, you mean that you apply that rule, and application of that rule or firing of that rule will result in the addition of certain statements, which is denoted by this make over here, to the working memory. Okay. Similarly, for rule 2, these are the preconditions and these are the after effects of firing that rule. And this, so at a given moment of time, there are multiple rules that may be fired for different production systems, different rules. In this case, I think it will be only one rule that can be fired at a time, at a point of time, but there can be other scenarios where you can fire multiple rules at a given point of time, and that will lead to what we will call a conflict set, which basically means that the set of all the rules and the working memory elements that can be fired at a given point of time, and then we will have to apply some conflict resolution strategies to decide which of these conflicting rules do we choose to apply or fire. Okay, but we'll see more of these in the coming questions. For now, let's focus on this just one simple question. So the first rule, what it does is it checks whether a particular natural number denoted by this num, whether this number is greater than 1. This is one condition. The second condition is it checks is whether this number n is even. If the number is greater than 1 and if it is even, then it divides it by 2, divides that number by 2, and it adds it to the working memory. If n is greater than 1 and if it's odd, these are the two things that rule 2 checks. Then it multiplies that number by 3 and adds 1 and adds that to the working memory. So if we keep applying this to the working memory element, so here the working memory element to start with is just one of it. This is one element, nat num13, which basically means a number of with value 13, which as you can see is greater than 1 and it's odd. So rule 2 will be fired, and 102, this is the new working memory element that will be added, and that will be nat num, and this rule 2 will be applied. So they will have 13 into 3 plus 1, which is 40. So 40 will be added over here. Next, we will try to see which of these rules are applicable for this newly added working memory element, which has value 40. Right, so in that case rule 1 will be applicable, so this will be halved, so it will become 20. Again it will be halved, it will become 10. Again it will be halved, it will become 5. Now again the second rule will be applied, so this will become 16. Okay, again after 16 it will be half to 8. After this it will be half to 4, then to 2, and then to 1. And once it has reached 1, you can see that no more of these rule 1 or rule 2 can be applied, because one of the preconditions for this rule is that the number has to be greater than 1, and we have a number which is equal to 1, right? So none of these rule 1 or rule 2 can be fired, so our production system will halt then and there, and this will lead to termination. Okay, so if I have to put it formally, this is what is happening over here. And okay, so yeah, um yeah, I'll let you go through this solution, and if you have any doubts, please feel free to let me know. We can go over the solution once more. um to address one message in the chat box, so I'm not sure about that, Rocky. I think he just might be busy. Bhaskaran sir just might be busy, so yeah, I don't think there should be any problem about it. Yeah, but he will get back, I think. I'll let you know whatever he lets me know. I'll let you know. But thanks for thinking about that. All right. So if there are any doubts about this solution, do let me know. I'll give you a couple of more minutes to go through this solution. Okay. So yeah. So I'll also go over the solution once more because there is a request in the chat box. Uh, so is there any particular part of the solution that you found confusing, uh, Lokesh? Or do you want me to just go over the solution in general once more? Okay, the complete solution. Um, okay, sure. Okay, let's go over the complete solution once more. So fire, yeah. So thanks for raising that doubt. So basically, firing a rule is equivalent to applying that particular rule, or selecting that rule for application. Okay, so let me just clear everything up. Okay, so basically what you have is you have a particular state. Okay, let this denote that state, and this has a certain set of, let's say, facts or statements. Okay, something like this. This basically indicates that in this state there is a natural number which has a value 13. Okay, this is, let's say, one fact or one statement in this state. Similarly, there are other states. Okay, um, what these rule based systems do is that they try to look for a particular pattern. Okay, that pattern is basically the preconditions of the rule. So what they'll do is they'll try to look for a particular pattern, and let's say this is the pattern that is required by a certain rule. Okay, once it sees that this pattern is present in this particular state, that rule will become applicable. Okay, and let's say there is this rule 1 that is applicable given this particular pattern, and if we end up applying that rule, then this will lead to some changes in the state, which is basically denoted by this make statement. It will lead to addition of a new fact to this um, working memory or the state basically, right? So the looks for a pattern. Okay, if that pattern matches, it does something else and results in the addition of something else to the state or some more elements to the working memory. Okay, so there can be multiple rules that may be applicable in a state at a given point of time. Okay, for example, these are the two, this, let's say this is the small pattern that is required for the application of rule 1. Similarly, let's say this is another pattern that is required for the applicability of another rule, and that will also lead to some other things. Okay, let's say this is some rule 2. So what these production systems or rule based systems do is that they look for these specific patterns, and if these patterns match, well, that is if the preconditions match, then these rules will become applicable. Now because there are different rules that are applicable at a given point of time, let's say at a given point of time you have rule 1, rule 2, rule 3, rule 1 with, let's say, two different arguments or two different inputs, input 1 and input 2, both. So all these four rules are applicable at a given point of time. So when I say a rule is applicable, that is what is exactly is meant by a rule is that we can fire a rule. Okay, which basically means that the preconditions of that rule have been met, and if we select that particular rule, then we will apply those particular changes that the rule results in. How we select which of these rules to fire, that is something that is dealt with by the conflict resolution strategies that we'll see more of in the coming questions. Okay, if there are multiple WMA which will be chosen, is it based on conflict resolution strategies? Yeah, so basically a rule can be fired with different configurations of your working memory elements, right? So yeah, each of those different configurations of the working memory elements along with the rule will constitute different parts of the conflict set. Um, what I mean to say is, uh, let me just draw a conflict set. Okay. Um, so let's say that this working memory element had one more fact that said nat num, let's say 3. Okay. So in that case, we can fire rule 2 with 13 as the input. We can also fire rule 2 with 3 as the input, right? So basically we have to select among these two rules to fire. How we will select which of these two rules to fire, that can be decided by a number of different factors. Some of them consider the working memory elements that are going as input, some of them consider some other things. We'll see more of those in the coming questions, so don't worry about it. And to answer the other question, if the rules are different, so that's okay. Rules can be different and rules are supposed to be different. If the precondition pattern of the rules matches, we can consider them to be applicable or to be a candidate for firing. Okay, so that doesn't matter if the rules are different or not. It's actually encouraged to have more such rules in more complex systems. Okay, so based on that, I hope the idea behind this firing of rules and the preconditions and the production systems and all is clear. Uh, if the idea behind conflict set and conflict resolution strategies is still a bit unclear, don't worry about it. We'll go through a couple of examples that will help you understand it in more detail. So don't worry about it. Uh, in this particular solution, so I hope now it's more clear to you that since the first and only working element in this particular working memory element state is 13, so we'll apply rule 2. um, which will result in the addition of 40, and then we'll apply rule 1 to 40, which will result in 20 being added. Then again rule 1 will be applied, then 10 will be added, and so on and so forth, and that is what is given over here. So first 13, rule 2 was applied with working memory element 101 as input, which is just this one. Okay, and that resulted in addition of 102, which is natural number 40. Similarly, in the next step we fired rule 1 with 102 as input, which is this one, and then we that resulted in the addition of this 103 working memory element. So these 101, 102, 103 basically represent timestamps. Okay, different time instances where these particular elements were added to your working memory element, working memory, not working memory element. So yeah, basically once you see an odd number, it will get multiplied by 3 with 1 added. If you see an even number, it will get halved. So just follow that pattern. So 13, so it's results in 3 into 13 plus 1, which is 40. Then it gets halved because it's an even number to 20, then 10, then 5. Again, it's an odd number, so 3 into 5 plus 1, which is 16, gets added. Then again, this is an even number, so it gets halved, 8, then again gets halved, then again gets halved. And finally, we reach this particular element, which does not satisfy any of the preconditions of the given rules. So our program terminates and we stop. Yeah, all of these 101 to 110, these are all working memory elements. Basically, elements that form a that form your working memory. Those are the working memory elements. The rule firing starts from 101. So basically, you see 101, and then you apply a particular rule. It may be that you arrived at your 101 rule itself by application of some other rules that is not given to you. That is not part of the question. So you'll just assume that you are given that you start with the fact that 13 is given to you in your working memory. Okay. So Sneha, you unmuted yourself. I think you were trying to say something, but it was not clear. Maybe can you write it down in the chat box? Okay. Uh, by the time, in the meantime, you do that, we can maybe go over the questions that were based on this particular problem, and it should be easy only. Because we have solved the whole problem. So let's go through the questions one by one. So when the production system is in flight, which basically means that the production system is running or the program is running, after the first two rounds of firings or basically applications of some applicable rule, the newly created WME, which is timestamp 103, is which of these? Okay, so you start with timestamp 101. So after the first firing, you will add something that will be timestamp 102, and after the second firing, you will add something that will be timestamp 103. Okay, so we just solved it. So which one will it be? What do you think? Okay, so as most of you say, it will be nat num 20, or 20 will be added because initially it was 13, so then you added 40, and after that you added 20. So 103 will have timestamp 103 will have nat num 20. That's correct. What about timestamp 106? As you checked, as we derived, timestamp 106 results in the addition of this 16 number, right? So here also option C would be the correct one. Again, pretty straightforward. Let's move on to the third question. So now that the production system has halted, in total, how many times was rule 1 fired? And what do you think? What will be the answer to this one? Okay, so we have received a couple of answers. Let's quickly check with our solution that we had. So this is the first time rule 1 was fired. This is the second time rule 1 was fired. Third time, fourth, fifth, sixth, and seventh time. Okay, so in total 7 times we fired rule 1, and let's quickly check the solution given to us. Yeah, 7 is the solution. So in total 7 times rule 1 was fired. Okay, I see a couple of you saying 6. I hope that's clear to you now. It's 7 times. Um, if not, please let me know. Okay, that's great. Um, let's move on to the fourth question then, which is the last question based on this particular problem statement. How many times was rule 2 fired? Okay, what do you think will be the answer to this one? 2. Okay, so most of you say 2. Let's check with our solution. This was one time when rule was fired, rule 2 was fired, and this was the second time when rule 2 was fired, and these are the only 2 times that rule 2 was fired. So yes, you are correct. The correct answer would be 2. Pretty straightforward again. Alright, I hope there are no more doubts with this particular problem setting. Um, if there are, I'll give you like maybe 1 minute. Please let me know, and then we'll move on to the next question then. Okay. If both rules are same, then the working memory will first go to rule 1 by default. Okay, so uh, it's a nice question, Abhishek, but see, the point is that you have different kinds of rules that match different patterns, right? So you wouldn't need to have two rules that are exactly the same. If you do end up having something like that, then yes, you can go with any of those rules, doesn't matter. But in general, you wouldn't have rules in a production system that are exactly same to each other. There might be some subtle differences in those rules, maybe in what they result in or what they have as preconditions. But yeah, nice that you think in that direction. um, any other questions? Okay, that's great then. Now let's move on to the next question or the next problem setting, which has a different set of rule, only one rule actually, and a different set of working memory elements in the working memory. Okay, so for the next few questions from questions 5 to 7, we'll be dealing with this particular rule and this working memory. Um, the working memory is already ordered by increasing timestamps, which basically means that your elements are given in the order of 101, 2, 3, and 4, and we have to allow the production system to run to completion until no more rules can be fired. Okay, and based on that we'll have to answer a certain set of questions. So you don't need to continue applying this rule until completion. Just try to understand what this rule means and what these working memory elements are. I don't want you to go on complete solving this particular production system until termination. Just try to understand what this rule is and what these working memory elements are, and then we'll move on to the questions. And then while trying to solve the questions, we'll see what aspects or what elements of the, or till what extent do we need to solve this program. Okay, so I'll give you a couple of minutes. Try to understand the problem setting, and if there is any doubt, please let me know. All right. So, would anyone like to share what they think this rule means? Anyone? Any guesses?
Hello, hello.
Yeah, I think I heard something, but not very clearly. Sorry about that. Um, yeah, yeah. If you want, you can please speak up again. But um, yeah, some of you have also tried to give some answers in the chat box. So basically, let's go over the different uh, parts of this particular rule. So the first part that we notice is that uh, this is the name of the rule. Okay, P vaccine 1A. Okay, this is the name of the rule. Okay, so we can give names to rules instead of just calling them rule 1, rule 2, rule 3, so on and so forth. We can give the name to rule. This is the name of the rule, which is P vaccine 1A. Okay, now these are the two preconditions that it needs to uh, have satisfied in order to be able to eligible to be fired or be applicable. Okay, so this some person X, okay, uh, some person with an ID X should be eligible. This is one condition. And then the date today should be Y. Okay, so if a person with ID X is eligible and today's date is Y, then what this rule will do is it will make a note that this person with ID X is supposed to receive the first dose of vaccine, let's say, in the uh, in the next 30 days, or Y plus 30, which basically means from 30 days from now on, it's this person with IDX is supposed to get the or receive the first dose of vaccine. Okay, so in terms of natural language, that is what this rule says. Um, so is that is there any confusion about what this rule means or what it's trying to do? Okay, that's great then. Um, let's move on to the questions then and see what exactly is being asked in this particular problem setting. So the first question is, how many classes are referred to in the rule given above? Okay, so as you saw, a while ago, I referred to something called classes in the context of rules. Um, so I'll show you the rule once more and I'll let you think how many classes do you think are present in this rule? Okay, so before discussing the solution, let's go over some example of what exactly is referred to by class and attribute and values. Okay, so this is a direct screenshot from the lecture slides or the lecture videos. So you can also refer back to your lecture videos or lecture slides if you want to. Okay, so basically this is an example of different working memory elements, and these bubbles denote the different parts of these working memory elements. Okay, so these 1, 2, 3, 4, 5, 6 they basically denote the timestamps. Okay, which in our case was 101, 102, 103, 104, 105, so on and so forth. Okay, so these are the timestamps. Then these things, these classes, this next, total marks, array, these are the different class names. Okay, and these small parts with a tiny pointy arrowhead to the left of it, these are the attributes. Okay, or if you are familiar with programming, you can say that these are akin to variables, and these attributes have certain values. Like this rank has value 1, this attribute student has value Sangeeta, this attribute marks has value 97, and this attribute rank has value nil. Okay, so you have certain classes. Within those classes you have certain attributes, and these attributes have certain values or may not have values, then it will be denoted by nil. Okay, so given that example, what do you think will be the number of classes in this rule? Remember that don't just look at the preconditions, look at the rule, complete rule together. Do you think the number of classes will be 2 or 3? That's right. It will be 3, right? Because you have this first dose over here as well. So one class would be eligible, another class will be today, and the third class will be first dose. Okay, so these are all different classes that this rule P vaccine A deals with. So there are 3 classes in total, and that's what is also given by the solution. The number of classes referred to in the rule is 3. Okay, any doubts about this question? Okay, that's great then. Let's move on to the next question, question 6. So next question asks, which of the following rule and working memory element tuples will be present in the conflict set? Okay, so tuples, if in case any of you are not familiar, is just something like this. Um, so a tuple will be, in this particular example, let's say this rule R is about to be fired and it will take as input, let's say 101 working memory element and along with it 102. Okay, so this thing within this bracket, this is a tuple. Okay, and if you are familiar with programming, then you would already know what a tuple is, but that's okay. So basically the question asks, which of the following rule and working memory element tuples will be present in the conflict set. So remember, the conflict set is the set of uh, different rules and working memory elements, the different configurations of them together that are applicable, okay, or can be fired given a particular set of timestamps in the working memory. Yeah, Shanti. So eligible was one class, today was another class. Let me just go back to the. Okay, so this is one class, eligible. Today is another class, and first dose is the third class. Okay, yeah. Now what you have to tell me is which of these rule. Let's say the rule is just R. Okay, you don't have to write the full P vaccine 1A. Just call the rule R for ease, for just your ease, and tell me which of these rule and working memory element tuples would be present in the conflict set. Okay, we already have one answer. What do the others think? So basically, when we what we want to say by conflict set is that the so let's first look at what are the rules that can be fired. Okay, there's only rules and working memory element tuples that can be fired. There's only one rule over here, which is p vaccine. For the sake of ease, let's just call it R. Okay, so this R has two preconditions. One is this eligible, one is this today. Okay, so we have one fact about today that is given to us, that today is 27 September 2021. Okay, so this will definitely be a part of the input that goes into the rule. Okay, but this eligible part of the precondition, this can be satisfied by any of these 102, 103 and 104. Okay, so you could have 101, 102. This could be one rule and working memory element tuple or pair. Then you could have 101 and 103, and you could also have 101 and 104. Okay, apart from these three, there are no other set of rules and WME tuples that can be applicable or can be fired. So we basically have to choose from these three options, uh, this one and this one, and choose which of these we want to fire. So that means that we have to resolve the conflict between these three set of rule and WME tuples. Okay, so this is what is forming our conflict set, and so there are three possible parts or elements in our conflict set. So the conflict set is a set of rules along with the inputs to those rules. Okay, those inputs we are calling as WME tuples, which basically means a subset of those a proper subset of those the set of all working memory elements from your working memory. Okay, here since the rule only takes two preconditions, it only requires two inputs. It can also be the case that some rule requires maybe three or four inputs. In that case, it won't make sense to call the rule takes a pair of working memory elements as its input. So that's why we refer to it as tuple. A tuple is basically a set of an n tuple is basically a set of n things together. Okay. I hope that answers your question. Um, yeah. So coming back to our question over here, which of the following rule and WME tuples will be present in the conflict set? The correct answer would be B, C, and D, because A doesn't make sense because we do not have any WME over here or working memory element over here that satisfies the eligibility precondition. Okay, both 101, 101 refer to the today fact, which is today is some particular date, and there's no information about the eligibility. So the correct answers would be B, C, and D. All right. Any doubts on this question? Okay, that's great. Then let's move on to the seventh question. Um, so, how many working memory elements will be present in the working memory after two cycles of execution, which basically means after firing of two rules? Okay, whatever rule that may be, that will be decided by some rule conflict resolution strategy. But let's say you decide something and you fire two rules one after the other. After the firing of two rules, which is what is meant by two cycles of execution, what will be the number of working memory elements in the working memory? What do you think? Okay, we already have a couple of answers. What do the others think? Yes, I'll give you a couple of minutes to think about it. So, in the question, we are not asked which rule will be fired. Um, we just need to concern ourselves with what will be the number of elements in the working memory after two rules are fired. Okay, so to start with, we were given four working memory elements. Okay, these four were already given to us. Suppose one of these rules is fired, then what will happen? And then suppose another rule is fired, then what will happen? So, if two rules are fired one after the other after this particular state, um, what will be the number of working memory elements? 4 plus what? What do you think? So, it will definitely not be less than 4 because we are not. So, this is not like we are removing something from the working memory. Okay, we are only adding things to the working memory. That's right. The number of elements in the working memory after two cycles of execution will be 6. Why so? Let's have a look. So suppose that among these this one and this one, we decided one to fire one of these rules based on some strategy. Okay, some let's say some oracle told us which of these rules we should fire or apply, and we decided to fire one of those. Since all of these rules correspond to the same name or same rule, which is P vaccine 1A, the result of whichever rule this will be fired will be addition of, let's say, for the first cycle of execution, addition of something first dose something something, right? First dose something 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 will be added. Okay. Now, even after this addition of this 105 element, the conflict set will remain the same, right? Addition of this 105 doesn't change the conflict set because none of these preconditions are affected by the addition of this 105. Okay, so the conflict set will remain the same. And after that, let's say another rule is chosen to be fired, which will be 106. That will again result in addition of the first dose something something. Okay, so the total number of elements in the working memory after two cycles of execution will be 6, which is 4 plus these two newly added elements, which is also what is shown by the solution over here. Yeah, so I understand your question, Rocky. So, like you said, these 101, 102, 101, 103, and 101, 104, these three are the possible pairs that go as input to the rule. But that doesn't mean that um, um, you will remove or make the application of the rule with any one of these pairs does not make the particular working memory element not eligible for application with some other rule later down the line, right? So this is basically a production system, right? A program, you may call it. It does not think in terms of uh, us humans. If it sees a pattern, it sees that pattern matches the preconditions for that rule, it will say that that rule is applicable to be fired. Okay, so it's not removing anything, so the total number of elements will not reduce, it will only increase. And the first cycle will result in addition of something, one thing, which is the first dose something something, so that will make it 5 elements. And then the second cycle will result in the addition of another element, which will make it six total number of working memory elements. Okay, so Sabrish, to answer your question briefly, what we were trying to do is we had a rule over here and a working memory over here, and we saw that which of these uh, working memory elements are among these 101 to 104, which of these are applicable or eligible to go as inputs to this particular rule, and different configurations of these working memory element tuples or pairs gave us our conflict set, because there is only one rule over here. So there is the same rule applied for different configurations of WMEs. And then the question asked us is, after two rounds of execution of this particular production system, which is basically uh, uh, application of two rules one after the other, or firing of two rules one after the other, what would the total number of elements in the working memory, which we just now discussed, will be 6. Okay, so in the first few questions, there was a rule like rule 3, nat num greater than 1, make nat num 5. Then how would it work? Okay, yeah. So yeah, that basically means that you're adding a rule that whenever it sees a number that is greater than 1, it will add 5 to your working memory. That basically means that as long as you have a number greater than 1 in your working memory, it will keep adding things to your working memory. So it will never halt, you can say. Okay, and yeah, there can be systems that have rules that don't halt, and that is one shortcoming. um, that's what my understanding says as of now, but yeah, you may also look at some of the resources, maybe the textbooks, about what they say on such things, uh, such situations. Yeah, I may be wrong also, but yeah, as of now, this is what my understanding says. uh, all right. um, okay, so any doubts about questions 5 to 7, or should we move on to the next few set of questions? Okay, that's great. Then let's um, okay, so yeah, I don't think it can be 5, like as one of you pointed out in the chat box, because of the reasons we just discussed. Uh, every time you, in the first cycle, when you apply a rule, it will result in the addition of something, first dose something something, as a element in the working memory, right? So that will be 4 plus 1 elements. And then when you apply the second rule, it will be 4 plus 1, right? So 6 elements in total after two cycles of execution. Okay, let me go to the next question, next few set of questions that will be based on written it. Okay, so let's go over the setting first. So this is basically certain eligibility conditions for different levels or different kinds of COVID vaccination uh, that will be given to us through this RetiNet. Okay, and this will be in an OPS5 like language. So basically, the different criteria are: those who are eligible or in the high risk category will get their first dose of vaccine. Okay, this is one rule, you can say. So this is written in the form of a natural language, a natural statement of English, but the written it will be translating it into certain in a certain fashion that you'll just see. So this is one rule. Those who are eligible or in a high risk category, they will get their first dose of vaccine. Okay, so this basically means that the rule would be something like uh, rule 1, eligible X or high risk category X, then arrow, make first dose vaccine X or something like that. Okay, then the next rule says the second dose is given 30 days after the first dose. The third rule says those with comorbidity factor in age 12 or more are in the high risk category. Then the fourth rule says that those who are 40 years or older are eligible for vaccination. And then the last rule says frontline workers who are below 40 years and are 12 years or above are eligible for vaccination. Okay, so these are 5 rules that are given to you. And a written net for the above is shown in the figure, which you just see. So the A1s and A2s are basically are the alpha nodes, and the B1s, B2s are the beta nodes, and the R1s, R2s are the different rule nodes. Okay, and what we have to do is we have to run the rate algorithm to for the given working memory. I'll also show you the given working memory, um, and yeah. So again, I won't expect you to solve this whole thing to completion. Just try to understand the problem setting, and then we'll answer a few questions based on those the RateNet that is given to us. Okay, so I'll just show you the RateNet once. So this is the RateNet that is given to you. I'll maybe zoom in a bit, and yeah, I'll let you go through this for a while, and you can try to familiarize yourself with this ATNet, and because we'll be working with this one for the next couple of questions. Okay, so I'll let you go through this for a couple of minutes. All right. So, any yeah, Amar, I was on mute until now. Is my voice audible now? Okay, thanks for that. Um, yeah. So, any doubts or confusion about this written net? So, basically, what this written net indicates is that let me use the laser light. Yeah. So, this beta nodes basically, or let's say that let's start with this one. This R1 basically. Yeah. Is there a question? Um, okay. Yeah. Feel free to mute yourself again or write in the chat box if there is a question. Um, okay. So this R1 basically indicates a rule. Okay, that results in this addition of this second dose for this person with IDX. Okay, and what are these preconditions for this rule? That will be decided by this uh, arrows coming into this beta node that is just above this rule. Okay, so the first thing that is coming into this is next equals to y. Okay, this has in turn an arrow coming into it from it equals to x, and this is an arrow coming in from first dose. So if you combine all of these together, what this means is that if a person with ID X has first dose scheduled on this next date of Y, and if today is date Y. Okay, so what this basically implies that if today is date Y and if a person with ID X has his or her first dose scheduled on date Y, next date Y, then both these will combine and your rule 1 will be fired, and that will result in the addition of second dose ID X. Okay, is that clear? Okay, maybe I might have read it in a slightly confusing way. For it to make more sense, I think this implies that if a person already has the first dose and his or her next dose is scheduled in a certain date Y, and today is that next date Y. Let's say that the person whose ID is, let's say, John, that person has the next dose scheduled on, let's say, 25th December, and today is 25th December, let's say, then you can say that that person will get the second dose, and then that John will have second dose uh, given to him according to the rule, and the second dose John will be get added to the will be getting added to the working memory. Okay, I think that should clarify it if there was any confusion earlier in what I said. So this was one rule. Similarly, there are other rules as well. For example, rule 2, which says that if today is date Y and if a person with ID X is at high risk, then we make that person X having the first dose of vaccine, uh, and the person will be having the first dose of vaccine and the next dose of vaccine in 30 more days. Okay, that is, I think, what was also shown in your problem statement earlier. Those who are eligible or in the high risk category will get their first dose of vaccine. Okay. Similarly, this rule 3 says that um, if today is date Y and um, person X is eligible, um, then again this first dose thing will be added. So remember, there was an or in that particular statement that was given to us, right? Those who are eligible or in the high risk category will get the first dose of vaccine. So That's why there are two rules that imply the same thing basically, rule 2 and rule 3. One with the high risk condition and one with the eligible condition. Okay. Then similarly, this rule 4 says that if a person with IDX has health with comorbidity is equal to present and that person's age is greater than 12, then we make him or her high risk. And if a person is a worker, with a frontline worker basically, with an IDX, and if that person's age is greater than 12 and less than 40, then we make him or her eligible. And if a person is greater than 40 years of age, then we directly make him or her eligible, which is rule 6. Yeah, so good observation. In some beta nodes, there is a variable, and some it isn't. I think that is just some uh, issue, printing issue with RetainNet. It doesn't really matter. Okay. Basically, you have, if you have a look at the rule, right? Um, yeah, yeah. I don't think it matters really. You can ignore that for a while, for now, for the time being. Yeah, but good observation. Okay. So if that is clear, let's have a look at the working memory as well. Okay, so this is the working memory that is given to you. So here the timestamps are given from 201 to 211. Okay, and we have facts like today is 27 September. Then there is a person with an ID Danny with an age 19. Sorry about that. There's a person with ID Jimmy with age 25. There's a person with ID Kelly with age 30. The health of Jimmy is such that he has comorbidity or she has comorbidity. Then there's a worker with an ID Kelly, that is a frontline worker. Then again there's a person with ID Manny with age 60, person with ID Bonnie, that's age 50. Again Danny has comorbidity, and then the first dose for Sammy has the next date of 27 September, and the second dose for Timmy is given. Okay, so these are the different facts that are given to you in your working memory, and you have to see which rules can be fired or which rules will form a part of the conflict set. So alpha nodes basically form a part of your conditions or the preconditions for a rule, and beta nodes are the ones that feed into your final output of the rule. You can think of it that way. Yeah, if you observe here, these blue nodes are all the alpha nodes that have the preconditions specified in them, and the beta nodes feeds into the final thing that the rule results in. Okay. For more concrete definition, you can try to have a look at the lecture slides. Maybe there you'll have something more concrete. But as of now, you can think of it in that terms. Um, yeah. So if that is clear, we can now move on to the questions that are based on this RetainNet problem. So the first question is, what is the location of the working memory element 201? And you have to enter your answer, enter the label of the alpha node. So if you see, each of the alpha nodes had a label A9, A10, A15, and so on and so forth. And you have to enter that particular label of the alpha node as a comma separated list if there are multiple alpha nodes where this particular element might reside in the RetainNet. Okay, so the first working memory element 201 was that today is the date 27 September 2021. This was a WME, and you are asked where exactly in the RetainNet will this particular element reside, which alpha node. That's right. So some of you say that it will be A9, which makes sense because A9 is where that today and date equals to a certain date that resides. So you don't need to mention A2 as long as you mention the last alpha node in that particular lineage, that will suffice. So you can only mention A9. Okay, because that date equals to y, that y value with 27 September 2021, that is residing in A9, right? So you just have to mention A9. So yeah, you're right. The answer would be A9. Now, what about working memory element 203? So 203 was person with ID Jimmy and age 25. Okay. Where in the retina do you think that will lie? Person with ID Jimmy and age 25. Okay. There may be multiple alpha nodes where this lies. That's right. As many of you said, this may lie. This will be lying in A18 and A19. Okay, because you are given that a person has ID X. Okay, so that is satisfied over here, but there are a few more things. So you need to consider go a layer more down, and this has basically A18 says age greater than equal to 12. Okay, so 25 satisfies this criteria, which is the age of Jimmy that is given to us, and then age less than 40 is also what is satisfied. So A18 and A19 are the two alpha nodes where this working memory element 203 might lie. So your answer will be A18 and A19. Yeah, so beta nodes are not usually considered, so you don't have to mention beta nodes. But um, if you were asked about beta nodes, then B5 would not entirely be true because B5 also requires another incoming edge from this, right? So if this was also true, then you could have said B5. But for this particular condition, that Jimmy with age 25, I don't think B5 will be applicable. So you're not asked about B5. If you were asked about B5, then you could say that it will be nil. Or if you were asked about beta nodes, then you could say it will be nil. Okay, let's move on to the 10th question then. Uh, the location of working memory element 211. Okay, so this might answer one of the query that you were just now talking about, Rocky. So let's see what 211 is. 211 is second dose for ID Timmy. Okay, so if you have a look at the rate net, where do you think will this be lying? Remember, the question is asking enter the label of the alpha node where 211 will be lying. I'll show you the rate net once more. I'll give you a couple of minutes to think about it. Yeah. So as some of you said, the answer will be nil, because if you see that working memory element 211 is second dose some TIMI, right? And that is not a precondition. That is the result of the application of a rule, which in this case happens to be rule 1, right? So there is no alpha node where this will be residing. Alpha nodes deal with the preconditions, right, as I said earlier. So there are no alpha nodes where this working memory element will reside. So the answer will be nil. Does that make sense? Any doubt about it? Okay, that's great then. um, Now we'll move on to some questions that deal with the conflict set. um, so now I would like you to have a look at the working memory. um, Okay, before that, to address a question in the chat, if one of the precondition fails, then the answer could be nil. So, answer to what exactly are you talking about, Sandhya? Um, if you're talking about whether a rule will be applicable if only one of the preconditions is true, then that will be false. The For a rule to be applicable, all preconditions must be satisfied. Um, yeah, only then the rule would be eligible to get fired. I hope that was what your question was asking, and that I hope this addresses it. But if not, please let me know. Um, yeah. So yeah, in this 11th question, what you're asked is you have to select or find out the number of instances of Rule 6 and Rule 2, which is basically you have to form the conflict set, which is basically you have to select all the rules that are applicable given your set of rules and your working memory elements, and you have to count how many times Rule 6 and Rule 2 appearing. Okay, so I'll show you the working memory elements once more. These are the elements. You can maybe take a screenshot of it, and then I'll also show you the rate in it, and then you can try to find the conflict set, and then we can discuss the solution also. Okay, so this is the working memory elements. This is the rate in it, and yeah, I'll give you a couple of minutes to try to find out the conflict set. All right, so I see a couple of solutions in the chat box. Um, let's try and solve it and see uh, how many times are rule 2 or rule 6 present in the conflict set. So let's take one rule at a time and try to see which of the WMEs fit into that rule. Okay, so the first rule is the two conditions that need to be satisfied are that today has to be a certain date and that date has to match with this particular statement with first dose for some ID having that next date as Y. So let's check. So there is one condition, first dose for ID Sammy and the next date is 27 September, and we also have today is 27 September 2021. Okay, so let us note down our conflict set over here. Okay, so one rule that we can apply is rule 1 with 201 and 210, right? You agree with me? Okay, let's see. There is no other first dose given anywhere else, so I don't think rule 1 can be applied anymore. Let's move on to rule 2. So rule 2 requires um, yeah, sure, I'll repeat once. Basically, if you have a look at rule 1, this requires two preconditions, right? One is that today has to be a certain date, and the other precondition is that some person with ID X with class first dose has his or her next vaccination scheduled on Y. Okay, so if a person with X has his next vaccination scheduled on Y and today is also date Y, then this particular rule will be applied and second dose will be added, right? So this is what match the two conditions given over here, which is today is 27 September and Sammy has the first dose and the next is scheduled on 27 September, right? So we can fire rule 1. Rule 1 is one of the candidates that can be fired basically. Okay, now let's have a look at rule 2. So rule 2 has two preconditions. One is today is a date something and then a person X is at high risk. Okay, or IDX is at high risk person, then this first dose something something will be added by rule 2. So let's see which of the working memory elements satisfy this. So today date is one thing that we have already, and let's say if we have a high risk somewhere. So we don't seem to have any high risk working memory element given here, right? Can you see any high risk working memory element? No, right? So which basically means that although one part of the preconditions for rule 2 is satisfied, no other preconditions, the other part of the preconditions is not satisfied by any of the working memory elements given in your working memory, right? So we cannot fire rule 2. Okay, so you can straight away say that the number of times rule 2 will be fired or will be present in the conflict set will be 0. So no rule 2. Fine, let's look at rule 3. Rule 3 says that if today is date Y and if a person with ID X is eligible, then again some first dose something something will happen. Okay, let's see if today and eligible match. So today is one thing. Eligible, do you see any eligible over here? There is no eligible, right? So even rule 3 can't be applied. So let's forget about rule 3 as well. Let's have a look at rule 4. Rule 4 says that if a person with ID X has health as comorbidity present and if the age of that person is greater than 12. Okay, so now let's have a look at that. Um, so this is one 205 is one element with comorbidity present, and is the is the age of that person greater than 12? Do you have any information on that? We are told that the age of Jimmy is 25, which is greater than 12. So we can fire rule 4 with 203 and 205. Okay. Similarly, let me remove this thing. Can you find any other fact with some comorbidity present and something, the age of the person greater than 12 over here? Okay, so the one information about Danny being having comorbidity present is given to you, but yeah, and then also the age of Danny is given as 19. So we can also fire rule 4 with a different combination, which will be 202 and 209, right? Yeah, that's right. Let's look at if there is something else. I don't think there is any other thing that can help in firing of rule 4. So let's move on to rule 5 now. Before that, let me just erase these. All right. So rule 5 says that if a person is a frontline worker and their age is greater than 12, greater than equal to 12 and less than 40, then this eligible thing will happen. Okay, so now let's look at if any of these three conditions are met in any of the working memory elements. So we are told that Kelly is a frontline worker. Okay, now let's see whether any information about the age of Kelly has been given. We are told that Kelly has age 30, which is again greater than equal to 12 and less than 40. So rule 5 is also applicable with 204 and 206. All right, and no other person with frontline worker information is given. So that's it about rule 5. Now let's have a look at rule 6. So rule 6 says that any person with age greater than equal to 40 uh, can be added as eligible. Okay, that is the only precondition that needs to be met: age greater than 40, greater than equal to 40. So that is satisfied by. Uh, let's have a look at the different things. So Manny satisfies that, right? So 207, then 208 will also be true because Bonnie has age 50. Um, is there any other thing that we can apply rule 6 with? That's the two things, right? Yeah. So we have gone through all the rules and we have seen all the different working memory element combination that we could use as inputs to the different rules, and we have arrived at our conflict set. So let's see how many times is rule 6 appearing. So rule 6 is appearing twice and rule 2 is not appearing anytime. Okay, so ideally the answer should be rule 6 is appearing twice and rule 2 is appearing 0 times. Does everyone agree? This is also the answer given to us. Um, Rule 6 appears twice, rule 2 appears 0 times. Yeah. So, Rocky, do you have any particular doubt in any specific part of the conflict set, or in general, do you want to go through it once more? The last two. Okay, so let's go through last two. Um, yeah. Let's go through the number of instances for Rule 4 as well, Shanti. We'll go through that. And Sabrish, I would suggest that since this is a public forum, I don't think it will be ideal for people to share their number or something. So if you want to contact someone from the some of your colleagues, I think it will be better to write it in the discussion forum and they can see it and address it over there. Unless they are familiar, unless they are okay with sharing the number, but that is not usually ideal in public forums. So yeah, I would suggest you follow that. Okay, let's have a look at our conflict set. So the last two were Rule 5 and Rule 6, right? So Rule 5 had um, three conditions. Okay, one was that the person should be a frontline worker coming from here. Then the age of the person should be greater than 12, greater than equal to 12, and less than 40. Okay, these are the three things that need to be satisfied for Rule 5 to be fired. And we see that so Kelly is a frontline worker, okay, and the age of Kelly is 30. 30 is greater than equal to 12, and 30 is less than 40. Okay, so all the three conditions are satisfied. Kelly is a frontline worker. Kelly's age is greater than equal to 12. Kelly's age is less than 40. So that makes Rule 5, all the preconditions for Rule 5 satisfied. So we can say that we can apply Rule 5 with these two inputs, which is person ID, Kelly with age 30, and that Kelly is a frontline worker. That's what we have written over here. And for Rule 6, Rule 6 basically tells us any person with age greater than equal to 40, just this part, okay. Any person with age greater than equals to 40 will have eligible added to it, eligible added in against his or her name by Rule 6. So all we have to look at is the number of people with age greater than 40, greater than equal to 40, which happen to be Manny and Bonnie, right, with age 60 and 50 respectively. So we can say there are two instances of Rule 6, one with input 207, which is Manny, and one with 208, which is Bonnie, right? So that is what Rule 5 and Rule 6 are. And to address what will be the number of instances of Rule 4, that will be 2, because Rule 4 is appearing twice, right? Over here, if you see Rule 4, Rule 4. So number of instances of Rule 4 will be 2. I hope that addresses both your questions, Rocky and Shanti. Okay, that's great. Um, okay, now that we have arrived at our conflict set, okay, now we'll have to choose how to apply some conflict resolution strategy to choose which of these rules we want to fire. Okay, so there are number of different conflict resolution strategies, some like something like recency or specificity or refractoriness or something like that. A number of rules have these conflict resolution strategies have been covered in the lecture videos, so you can go through all of them at your own time, but here we will discuss maybe one or two of them which are most commonly used. One is recency and one is specificity. Or let's cover recency first and then specificity you can also look at on your own. It's relatively easy. So let's see that how will recency help us in resolving the particular conflict. Okay, so basically what recency says that among these working memory element inputs that are given to the different rules, we have to basically arrange them in descending order. Okay, so if I have to uh, write that down once more, uh, if we can write this down as, let me erase all of this so that we have some more space. Okay, so let us rearrange all these rules and WME tuples in with their individual inputs in descending order. Okay, so this will have 210 first and then 210, Then this rule 4 will have 205 first, then 203. Then this again rule 4 will have 209 first, and then 202. Then this rule 5 instance will have 206, then 204, and this rule 6 only has one input, so that will remain as it is. Okay, so is this step clear? What we just did in this step? Okay, now if this is clear, now what I want you to do is, I want you to arrange all these different instances of different rules. Maybe rule 1, rule 3, rule 4, rule 4, rule 5, rule 6, whatever. Whatever rule you have, I want you to arrange these on the basis of the timestamps that are given as inputs. What I mean by that is that consider this first timestamp first. Okay, so the first timestamp for rule 1 is 210. That for rule 4 is 205. For rule 4 again is 209. For rule 5 it is 206. For rule 6 there is only one and only timestamp, which is 207 and 208. So if you arrange it based on the first timestamp only, you will have a certain order, right? Fine. And then try to compare it based on that particular timestamp. Okay, and the one having the latest or the most maximum timestamp will be the one that will be chosen at most recent, or the most recent rule WME tuple that you can fire. What I mean to say is summarized in this particular set of statements over here. Let's just go through that. In a conflict set for two conflicting instances of same or different rules, recency is decided by listing the WMAs in descending time sequence and comparing the ordered lists and selecting the dominant one. Okay, so consider this example conflict set that is given to you. For some rule, let's say these three timestamps are the inputs: 210, 208, 207. Okay, then for another rule 7, let's say 208, 202, and 201 are the timestamps. And then for some other rule 2, 209, 8, and 7 are the other inputs. Now, if you notice, these have been arranged in the descending order. Time tags have been arranged in the descending order, both within these rules and across rules. So if you see this in individual rules, 210 comes before 208 and that comes before 207. Similarly, in the second one, 210 comes before 202 and comes before 201. Again, in the third one, 209 comes before 8 and 7, right? So within each rule, you have the timestamps arranged in a descending order. And then across rules also, you have these arranged in descending order. So, for example, if you consider the first one only, you see that rule 1 has 210, right, which is greater than 209 and equal to 210. So you arrange it in this order. Then you compare the second one. Okay, and if that is also same, then you compare the third one in order to decide which comes first. Again, this is explained over here. For two lists of time tags in descending order, let's say we have T1, T2, T3, S1, S2, S3. We will first compare the first timestamps, okay, which is T1 and S1. Okay, if T1 is greater than S1, we will say that the first one will be fired. If T1 is equal to S1, we will say that we will now compare T2 and S2. Okay, if T2 and S2 are also same, we will compare T3 and S3. So on and so forth, we'll keep going until one winner emerges. Okay, and if one of the list runs out of time tags, then the longer list is the winner. Otherwise, both are winners, and this in this case, the we can choose the rule to fire by their rule index. Let's say if all these T1 equal to S1, T2 equals to S2, and T3 equals to S3, then suppose the first one corresponded to rule 1 and the second one corresponded to rule 5, then we'll go with rule 1 based on the rule index. Okay, so this is how recency decides which rule to fire. And in our case, if you see that among all the rules and WME tuples we have, Rule 1 with 210 as the first timestamp is the one that will take the first place in our descending order list, right? So rule 1 will be the one that will be chosen to be fired by recency as the conflict resolution strategy. Okay, is recency clear? So Abhishek, what do you mean by can we write on rule x1? Um, Example. Okay, we can take this example itself. Let's write that down in a certain order. Okay. So the first one will be rule 1 with 210 and 201. Let's see what the next one will be. Next we have 209, right? So let's write that down. This is R4, not R2. 209 and 202. Next, what do we have? Next we have R6 with 208. So let's write that down. Then we have R6 with 207. Then we have R5 with 206 and 204. And finally, we have R4 with 205 and 203. Okay, so you see that you have arranged all your rules based on the first timestamp, right? Which has 210 appearing before anyone else. So R1 will be chosen according to recency. The rule will contain all the WMEs that are part of its precondition, right? So that may contain both statements, one statement or multiple statements depending on how many of its preconditions are satisfied, or which of the working memory elements help it satisfy all its preconditions, to put it in a better way. It's descending because you see 210 is higher than 209, right? So if you go by the word recency also, the higher the timestamp, okay, the greater the timestamp, which means that the more recent that element is in your working memory, right? So that, I hope that gives an intuition of why recency is based on its descending criteria. So I hope that addresses your query. Um, yeah. So with that, we are at the end of the questions for today. Um, Let me just quickly check one question that was posted in the chat box. So, Dr. Ashwini, is your question from the current assignment? Rocky, to address your question, yeah, it's written 201 first. You can just ignore that. 210 should be first. That is just a typo.
So what is the typo in that?
Basically, 210 should be before 201. It doesn't really matter, but yeah.
So actually, in the text I texted you, the one line is in red color. Okay.
Just give me a minute. So the typo I was referring to was with something else, not with your question. So sorry about the confusion if there was any. Um,
Okay.
just give me a moment. So Rocky, I'll just come to your question, Dr. Ashwini. Let me just address something that Rocky had raised before. So the reason why this is in R120, 201 and 210 is that the question asks us to put it in that way. So if you look at the question over here, it says that your answer must be comma separated list starting with the rule label followed by the timestamps of matching WMEs in increasing order. Okay, so even though you have arrived at your final solution using the recency test, which needs you to apply things in descending order, you have to present your answer in a certain way that is given over here in the asked in the question, which is increasing order. That's why you have written 201 before 210. Okay, that's what it is. And to answer another question, um, the number of instances of rule 1 you got is 4, but the answer is 1. Okay. Maybe you can try to see if you arrived at the conflict set properly. If not, you should raise it in the discussion forum. If there is an issue in the practice assignment, then I will encourage your colleagues or maybe Bhaskar and sir to look it up. Um, yeah, that's what I will advise. And yeah, coming back to your question, Dr. Ashwini, yeah. So, what can you please, sorry about asking you to repeat your question again.
Yeah, yeah, yeah. Actually, in the rule 2, third line,
Okay.
is there any operator missing? Because after attribute A, uh, y less than x is given.
Okay.
So from where we have to take the value of x there.
Um, so x is given to you in the previous statement, right? Nat ax.
Okay, that means at every uh,
For
memory, at every timestamp, we have to update to.
just
mm,
look at it in terms of simple pattern matching. Okay, if the preconditions of those rule match, which basically means that if some natural number with uh, value, let's say x, is one precondition, and the other one is that some other number, let's say y, is less than x, and there is some other thing b with z, then you do something, right? um, I don't know if this makes sense, but that's
yeah.
what I can infer from this.
Okay. One more thing, actually, the A, there are two classes. One class is NAT, another class is REC, right?
Yeah.
So in that, the NAT A is not same as RECA, right?
Um, the attributes can be shared across classes also. So yeah, it really depends on the question you're working with. It can be the same thing as well.
It can be same.
Yeah, I think so. But yeah, maybe I need to think more
Because in
about
the
it.
textbook I have seen, yeah, in a textbook it is given like two different classes and do different memory elements.
Yeah, classes can be
Because each class
different.
is
If you
so
take
attribute name may be same, but values may be different from class to class.
Yeah, so if you have a look at
So
one of the examples that we discussed, so this also
yeah,
had something like,
so what are the examples you discussed? Only one class is there. Seems.
no, no. So see, okay, yeah, see, this high risk also takes this attribute ID. This eligible also takes this attribute ID. Person also takes this attribute ID, right? So this ID is shared across high risk, eligible, and person. So different classes are sharing this ID. So based on that, I was saying that different classes can have the same attribute as well. But yeah, I'll
Same attribute but different values.
different values may be present. Yeah, so attribute can be like a variable
But
itself.
at any given timestamp, we may have different values for the say for the attribute name. Same attribute name is same, but it may present in different classes.
Yeah, that's true for any variable, you could say.
Okay.
Yeah,
Okay. Okay. Thank you.
sure. Yeah, Rocky, you had raised a hand. Okay, yeah, about specificity you wanted to ask, right? So specificity is another conflict resolution strategy where basically you will have a look at which rule and WME tuple is most specific. If I want to elaborate more on more specific, you can say that which of these requires the most number of conditions to be checked. Okay. So, for example, if we consider our conflict set, which included rule 1, rule 4, rule 6, and rule 5. Okay, so let's consider them one by one. Rule 1 required checking of two things. Okay, one from this side, one from this side. Similarly, rule 5 required checking of three things, one from here, one from here, one from here. Okay, rule 6 required checking of only one thing, just from here. And rule 4 required checking of again two things, one from here and one from here. So the maximum number of checks are occurring in the rule 5. So you can say rule 5 is the most specific. So if you have to select a rule WME tuple based on specificity, your answer will be rule 5. Does that help? Okay, that's great then. So yeah, these were the questions for today. And yeah, again, we are short on time for discussing the other questions from the previous um, live sessions. And I'm sorry about that, but I can't do anything about it. I have sent a mail to Bhaskaran sir, and I'll see if he can get the solution updated in the discussion forum as soon as possible. Yes, I will upload the Jamboard as right now only. And yeah, that's it about today. Thanks everyone for joining, and let's meet next week.